In this video we're going to look at how we can use the cosine rule to find missing lengths in a triangle. And the cosine rule tells us that a squared is equal to b squared plus c squared subtract 2bc cosine a, where the lowercase a, b and c are the three lengths of the triangles, and the capital letter A is the angle opposite the length of the lowercase a. And this works just as well if we switch it round, so we could write it as b squared equals a squared plus c squared minus 2ac cos b, or c squared equals a squared plus b squared minus 2ab cos c. Well, we generally just need this one form. Now I've got to make sure that the letter that I'm looking for here, so the length of this side, is matching up with, in this case it is this term, because it is opposite the angle, and the only one that here is fixed is that the angle that we're using has to be the capital letter, so it has to be the A. So I can do a substitution here, so a squared is equal to 3 squared plus 8 squared minus 2 times 3 times 8 cosine 30, and I can evaluate that now on a calculator. So 3 squared and 8 squared minus 2 times 3 times 8 times cosine of 30, and I've got my answer here of 31.4 degrees, not degrees even, because this is a length. And then I'm going to find the square root of that, so square root answer to evaluate A, and I'm going to give this to three significant figures, so 5.61 centimetres. Now, second example, I'm going to go through the same process. So here I've got my angle, so it's the opposite angle which I start with, so opposite side I start with, so here I've got 9 squared is equal to a squared plus 5 squared subtract 2 times 5 times a cos of 50. And now I'm going to simplify this a bit, so I'm going to write it as 81 equals a squared add 25 subtract 10a cosine 50, and here I've got a squared and a in my equation, so I've got a quadratic, so I'm going to rearrange it to make it equal to 0. So a squared subtract, and I'm just going to rewrite 10a cos 50 is 10 cos 50 multiplied by a, and then I'm going to subtract the 81, so 25 subtract 81, negative 56, and that is equal to 0. And it's important that I have rearranged this, so now I'm going to use the quadratic formula to solve. So treating this as a quadratic, I'm going to say that the value of a, so the coefficient of a squared is 1, b is then the coefficient of in this case a, so that is negative 10 cosine 50, and then the value of c is the numerical term on the end, so that's negative 56. Now, probably I should have used a different letter because I have A here and this A means something different, but I've kept it the same in this instance just because you're familiar with A and B and C, hopefully from using the quadratic formula in C1. So what I'm going to do now is I'm going to evaluate this using the quadratic formula, and because I've got this horrible term for B, I'm actually going to use the calculator just to help me out a bit. So what I'm going to do is I'm going to input my coefficients and I'm going to store them. So A is 1, so I'm going to put 1. and I'm going to do shift STA, which is store, and I'm going to store that as A. So it's come up saying the answer has gone to memory A. And then I'm going to do -10 cosine of 50, and I'm going to store that in memory B, and then C was -56, so I'm just going to type in -56, and I'm going to store that in memory C. And now I'm just going to type in the quadratic formula. So I've got minus B plus or minus, so I'm just going to do plus the square root of B squared minus 4AC all over 2A. So that's given me a value of A, so A is 11 point, I'm going to use the three significant figures, so 11.4. And now all I need to do is I need to just scroll back through here, and then I'm going to just change the plus to a minus to get my second solution. So hopefully you can see that what's written in there is just the quadratic formula with A's, B's and C's, and that gives me an answer of -4.9. and then I can reject one of my answers because I'm not going to get a negative length, it's not going to make any sense, and so I have my value of 11.4.